Alright, so in this video, I'm going to be solving a system of equations. So in my system of equations, I have two equations. My first is AB plus A is equal to 32. So this is going to be my first equation. And my second equation is going to be AB plus B is equal to 35. So to solve this system of equations, I have to find the value of A and B. So to start out, what I'm going to do is subtract equation 2 from equation 1. So equation 1 minus equation 2. Equation 1 is AB plus A equals 32. So I have AB plus A minus AB plus B is equal to 32 minus 35. So to solve this, what I'm first going to do is distribute the negative sign. So now I get AB plus A minus AB minus B is equal to 32 minus 5, which is equal to negative 3. Now I can cancel out AB and negative AB, so I'm left with A minus B is equal to negative 3. And this means that A is equal to B minus 3. So now what I can do is substitute this value of A into equation number 2. So equation number 2 is AB plus B equals 35, right? Well, now that I've got a value of A in correlation to the value of B, I can plug this in. So now I get B minus 3 times B plus B is equal to 35. And now my only variable in this equation is B. So we can solve this. What I'm first going to do is distribute the B. B times B is B squared, and B times negative 3 is negative 3B. And now I have this plus B, which is equal to 35. And negative 3B plus B is equal to negative 2B. And if I subtract 35 on both sides, I get B squared minus 2B minus 35 is equal to 0. Now from here, what I'm going to do is actually add this back because we did miss a step. So B squared minus 2B is equal to 35 once again. Actually, before doing that, what I'm going to do is add 1 on both sides. So now I have B squared minus 2B plus 1 is equal to 36. And now the reason I did that is because B squared minus 2B plus 1 is the same thing as B minus 1 squared. And now I can take the square root on both sides because the square root of 36 is a whole number. And now I get B minus 1 is equal to positive or negative 6. So this gives me two equations. I get B minus 1 is equal to positive 6, and B minus 1 is equal to negative 6. So for B minus 1 equals positive 6, I can just add 1 on both sides, and I get B equals 7. And for B minus 1 equals negative 6, I can again add 1 on both sides, and I get B equals negative 5. So now from here, I have to plug this back in to this equation right here, AB plus B equals 35. So if B equals 7, I get 7A plus 7 is equal to 35, meaning 7A is equal to 28, and A equals 4. So if A equals 4, then B equals 7. This is one solution to my system equations. And now if B equals negative 5, I get negative 5A minus 5 is equal to 35, meaning negative 5A is equal to 40, and A equals negative 8. So if B equals negative 5, then A equals negative 8. So these are my two solutions. Alright, so in this video, I'm going to be solving the equation x to the power of x is equal to x to the power of 2. So, my only variable in this equation is x, so that's obviously the variable which I'm going to be solving for. And now for my solution. I'm going to first write my equation down here. So I have x to the power of x is equal to x to the power of 2. And I'm going to first start by dividing both sides by x to the power of 2. So I have x to the power of x over x to the power of 2 is equal to x to the power of 2 over x to the power of 2. And x to the power of 2, x to the power of 2, these two cancel out. So now I'm going to be left with x to the power of x over x to the power of 2 is equal to 1. Now from here, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2 is going to equal x to the power of x minus 2, which is equal to 1. Now I can take the ln or natural log on both sides. So I have ln x to the power of x minus 2 is equal to ln of 1. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this can equal b times ln a. And this property is very useful because notice how now x is an exponent, and in this state it's really hard to solve for x. But now, using this property, I can move it to the front, and now it's an actual term and it's much easier to solve for it. So I get x minus 2 times ln x is equal to ln 1, and ln of 1 is the same thing as 0. So I have x minus 2 times ln x is equal to 0. Now from here, I get two equations. I get x minus 2 is equal to 0, and I also have ln of x is equal to 0, meaning 2 equals 0. And all I have to do to solve this is to add 2 on both sides. So then these two cancel out, and I'm left with x is equal to 0 plus 2, which is 2. Now, for my second equation, I have ln of x equals 0. And this is basically asking ln of what is equal to 0. And, well, we already know ln of 1 is equal to 0, but what if we didn't know this? Well, what we can do is take e to the power of both sides. So I have e to the power of ln x is equal to e to the power of 0. And e and ln, these two cancel out. So I get x is equal to e to the power of 0, which is 1. So now that I have two solutions for x, what I'm going to do is check to see if these are right. So my equation is x to the power of x is equal to x to the power of 2. And let's first start by checking 1. So if x equals 1, I have 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1, so this is right. And now I'm going to check x equals 2. So I have 2 to the power of 2 is equal to 2 to the power of 2. 2 to the power of 2 is 4, so I get 4 equals 4, and this is right as well.